Welcome. This is Algebra 2, Semester 2, Unit 9. This is Section 3.2. Today, instead of graphing to find the solutions of systems, we're going to use substitution or elimination. This is kind of a review of Algebra 1. So if it's been a while, be patient with yourself, have a lot of grace, and just realize you can rewatch these videos, you can pause them, you can stop them, but this is a skill you need to have for this test. With substitution, I only use that if it's real easy to get a variable by itself. See how this x is almost by itself, we just need to subtract 5y? That would be a perfect situation for substitution. You could use elimination, but I just like to use it when I can. I use the substitution. So I subtract 5y from each side, and I find that x equals negative 5y minus 9. Now I put that whole thing in parentheses. Sometimes I'll even circle it, and I say that will replace the x right there. So I write the equation, but instead of putting the x in there, I put in negative 5y minus 9. Very important that you use parentheses to put it in. Then I bring down the rest of the equation. Plus 3y equals negative 2. Now I distribute to get rid of the parentheses. Negative 20y minus 36 plus 3y equals negative 2. Negative 20y plus 3y, using the commutative property, we've just rearranged those. Like terms together. That would be a negative 17y minus 36 equals negative 2. I would add 36 to each side, and I would get negative 17y equals 34. Because a positive 36, when it comes across, and a negative 2 is a positive 34. Now I divide by negative 17, and I get that y is equal to negative 2. Now I need to take that and plug it back into one of these equations, because just like yesterday when we were graphing, we had to come up with the point, we have to come up with the x and the y value here to know what the point is that they're intersecting at. So I take this negative 2, plug it in for y. I'll just use this equation. X plus 5, instead of y I put negative 2, equals negative 9. So x minus 10 equals negative 9. X, add 10 to each side, equals 1. So I have these circled only because I figured out what my independent variables are from each other, but now I need to give the answer as a point. So it's 1, negative 2. I am saying those two lines cross at that point. That is my final answer to the question. Going down to the next one. I don't have a variable by itself, so elimination is the easiest thing to do. I can either try to get these two variables to be opposites and eliminate them, or these two. I see that it would be very easy to multiply this one by 3 and they would be opposites, because then I would have a positive 9 and a negative 9. So I take this upper equation and I mark that I'm going to multiply everything in it by 3. 3 times 3x is 9x. 3 times 3y is 9y. 3 times negative 15 is negative 45. Now I add these equations with each other. 5x and 9x is 14x. Positive 9 and negative 9 will cancel each other out. That's the whole reason that I did that. If you don't end up canceling one of your variables, then you've done something wrong, because elimination is eliminating a variable. Negative 45 and 3 is negative 42. Now I divide each side by 14 and find that x equals negative 3. Just like in the other problem, I have to plug that into one of these equations to find what my y is. So 5 times negative 3, and it doesn't matter which equation you use, they'll come out the same. 9y equals not negative 3, positive 3. Okay, 5 times negative 3 is negative 15, minus 9y equals 3. We're trying to get y alone, so we'd add 15 to each side. Negative 9y equals 18. Divide by each side by negative 9, we would get negative 2. Okay, so we now know that our point is negative 3, negative 2. Okay, next problem. To get opposites here, we would have to multiply the bottom by 3 and the top by 4. Opposites here would have to multiply by negative 6 and by 7. Actually, not by negative 6, just 6 and 7. I'm going to go with the 3 and 4. I just trust myself better on a tired day that I can do the smaller numbers better. So that one would be multiplied by 4, this one by 3. So 4 times 3x is 12x. 4 times negative 6y is negative 24y. 4 times 9 is 36. That is the most common error, is to forget to multiply by that final number. Make sure to do that. 3 times negative 4x is negative 12x. There's my opposites, just what I wanted. 3 times 7 is 21. 3 times negative 16 is negative 48. So let me add these together. 12 and negative 12 cancel out. Negative 24 and a positive 21. Subtract them, we get 3. The sign of the larger one's negative. So or I should say the one farther from 0 is negative. So we have the negative on the 3. 48 minus 36 is 12. The one farthest from 0 is negative, so the answer is negative. Now we divide by negative 3, and we find that y equals positive 4. Now we plug that back into one of the equations. 3x minus 6 times 4 equals 9. 3x minus 24 equals 9. Add 24 to each side. 3x equals 33. X equals 11. So our final answer is 11, 4. We just divided by 3 on that last step there to get that. So that's the answer to the whole problem. 2 more here. Here I would multiply this bottom one by 3, and that way I can cancel my x's. So I get negative 6x minus 15y equals 27. I bring over the other equation, 6x plus 15y equals negative 12. So my x's cancel, just like what I wanted. Ooh, but now my y's cancel. I have nothing left over here. And on this side I have 15. So the question is 15 equal to 0? The answer is no, so this is no solution. Anytime you eliminate all your variables, it's going to be either no solution or it's going to be infinitely many solutions. But if it's not true, then it's no solution. Okay, next one. I'm going to multiply the bottom one by 3 to eliminate my x's. So I get negative 12x plus 3y equals 9. Now, I write the other equation right above it. 12x minus 3y equals negative 9. The x's cancel. Ooh, the y's cancel. And my other number cancels. So I end up with 0 equals 0. That is a true statement. So that is infinite solutions. Because that means anything that I plug in there, any value that I plug in for x, it will make that true. Okay. That is the end of that section. Thank you very much. See you tomorrow in class.